Hello classes, this is Mr. Holmes. Today we're going to be talking about square roots and cube roots, as well as rational, irrational numbers. We're going to get into the meaning of it. We did talk about it earlier in the year, how to do a square root on the calculator, but we're going to go into more detail as to why the answer is what it is. So we're going to first start with some definitions, and then we'll get to some examples. So the first thing with square roots and cube roots is when you do it, you're going to see this weird looking symbol. Looks like this. Kind of looks like a check mark with a little thing above. This is called a radical. It's used in square roots and cube roots. When we get to cube roots, you'll see a little 3 that's next to it, but whenever we deal with square roots and cube roots, you will see this radical when it wants you to form. It's called a radical, and it's read as either like the square root or the cube root, which you'll see later on. Now we'll get into some more definitions. The first one is perfect square, and we're going to later make a list of perfect squares. A perfect square is a number whose square root is an integer. And okay, so again, a number whose square root is an integer. Integer just means no fractional component. No fraction component. So basically, I don't want anything after my number, just 9 or 15 or -4. No 4.2, 4.73, none of that. So it just ends right after your whole number part. Okay, so that's a perfect square. This next definition is a square root. A square root is one of the two equal factors of a number. Basically, I'm multiplying a number by itself to equal a number. It's the same number. And we'll get into that a little more in just a bit. The other two definitions we're going to look at are cube root and perfect cube. So a cube root is like we'll start cube root, one of 3 equal factors of a number. So instead of 2, it's 3 numbers multiplied together, the same number, 3 times to get your number. And this is your abbreviation for that number, just like a hashtag. And perfect cube. Perfect cube is a number whose cube root is an integer. So basically no fractional value when you calculate it. I don't want anything like 9.2, just 9 or 10. So those are the main definitions for square root, cube root. There's 2 other ones because when you do take a square root or cube root, sometimes you'll get an integer answer or sometimes you may get a long decimal. And this will, based on each, either be a rational number or an irrational number. So the last 2 definitions we're going to talk about are rational number and irrational number. So a rational number is a number that can be expressed as a fraction. Of 2 integers. So a number that can be expressed as a fraction of 2 integers. And we'll do some uh, examples for this. So my examples for this, I can do, for example, 3, because I can write 3 as a fraction, 3 over 1. I could also do -3. So any integer is a rational number. I could also do decimals that end. 0.25. If I convert that to a fraction, that's 1/4. I could also do numbers that repeat. For example, 0.6 repeating all the way is really just 2/3. And fractions. Any fraction is automatically a rational number because that is the definition. For example, 4.5 I can write as 9/2. Negative numbers work too, so -0.6 repeating, -4.5, so on. So those are examples of rational number. If I can write it as a fraction, it's good. Basically, it's either a number that repeats or terminates. Irrational number is basically the opposite of a rational number. It is a number that can't be expressed as a fraction. A number that can't be expressed as a fraction of 2 integers. So I can't write it in fractional form. And there's 2 basic types of numbers. Another way to think of a rational number is a number that doesn't repeat or doesn't terminate. Which just means end. So basically, if I have a number that goes on forever, it will be irrational. However, there has to be no pattern for it. It can't be like 0.6 here. 0.6 goes on forever, but it's the same pattern. It can't have a pattern. You can't predict what the next number is. So if I knew 100 digits, I wouldn't be able to figure out the 101st digit based on it. And there's 2 big examples for this. The first one is pi. Pi is an irrational number. It goes on forever, no pattern, 3.14159, so on. You can't predict what the next number is. It just goes on, no pattern. And the other types of irrational numbers you'll see are non-perfect squares and non-perfect cubes. This would be, for example, square root of 2 or the cubed root of, say, 7. That's a little 3 right there. So those would be examples, and I'll show you how to do that on your calculator in a little bit. When you plug those in, you're going to see they go on forever. There's no pattern involved. So those are your definitions. Now we'll get into the meaning behind all this. Okay, so the first thing, we're going to talk about our squares. So I can see something written like this, x squared. This is a square. Basically, I'm taking x, I'm multiplying it by itself. X times x is x squared. And I'm trying to figure out what number it equals. So when I square a number, what number times itself gives me the number here. So if my number was 5, it'd be 5 times 5. The second way is you'll see something like this. The radical sign with the x underneath will be some number. This is called square root. This is the opposite of squaring a number. Basically, it's saying, what number can I multiply by itself that will equal the number underneath the radical sign? So for example, if I had 9 underneath it. What number can I multiply by itself to give me 9? I could use 3, whereas 3 squared is 9. So square root of 9 is 3 because 3 times 3 equals 9. You use squaring when you want to calculate area, and you use square root when you're given area. So when you want to find the area, you square. When you're given the area, you need to figure out the missing side if it's a square, and you work backwards. So when you want to calculate the area of a square, you use the first way. When you're given the area of a square and you want to find the missing side, you use the second way. Third way is now when we deal with cubes. So x cubed. This is when we want to deal with a cube. This is for calculating volume. It's basically just saying, if I need to find the volume and I'm given the side of a cube, I'm just going to multiply it by itself 3 times. So the side times the side times the side gives me my answer. So if my side was 5, it'd just be 5 times 5 times 5. On your calculator, there is a way to do the cube button. If you have the regular standard scientific calculator, if you look, in green underneath the 0, there is a cube root button. It looks cube root of x. You use second 0 to do it on your calculator, the cube root. And to do the regular cubed, we look for the x3 button. There's x2. x3 is above the 1. So second 1 does x cubed. So for volume, I use second 1. That does a cubed on the calculator. So for example, 5 cubed equals 125. I would do 5 second 1, 125. There's also this y to the x button we could use for any. If you want, you hit the 5, hit the y to the x, you can hit 3. You can also get 125. Both work, but I'm going to focus on the second one, the cubed here, for now. And the last way is your cube root. It's written like this. So very similar to the square root of x. When there's no number there, it's implied to be a 2. If there's any other number, then you use that as your root. So this is cube root of x. Cube root. This is when you're given the volume. When you're given the volume of a cube, you have to work backwards. So this just says, basically, what number could I multiply by itself 3 times to give me my volume? To do this on your calculator, I use second 0. So for example, if I had, let's say, 343 as my volume, I could do the cube root of 343. So what number times itself is 343? It's 343 second 0, and I get 7. 7 times 7 is 49, times 7 is 343. So that's how you go about calculating a cube root of a number. What number times itself? These are perfect cubes. So just know, when I'm squaring something, I'm finding the area of a square. Square root, given the area, I'm finding the missing side. Cubing, I'm finding the volume. And cube root, given the volume of a cube, I'm finding the missing side. So those are the 4 scenarios. Now we're going to get into our perfect squares, perfect cube list. And it's very helpful to know these. If you know these, it just makes it a lot easier to do. So perfect squares. I'm just going to go up to 12. Basically, I'm just multiplying a number by itself to get your answer. 1 squared is 1. 1 times 1. 2 squared is 4. 2 times 2. 3 times 3. 3 squared, 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. And 12 squared is 144. So whenever you see any of these numbers, it should just automatically be, oh, these are perfect squares. I can make a square perfectly using the sides. So if I said the area of a square is 81, you should automatically know, oh, 9 times 9, 81. And we'll do some examples of this later on. These are your perfect squares. You can know more up above 12. If you want to know up to 20, feel free. But really, up to 12 is what you need to have memorized. Now we have our perfect cubes. Perfect cubes, I'm just going to go up to 10. So instead of timesing it by itself, I'm timesing it by itself twice. So number times the number times the number. So if I start with 1, 1 cubed, 1 times 1 times 1 is 1. 2 cubed, 2 times 2 times 2 is 8. And so on. 3 cubed is going to be 27. 4 cubed, 64. 5 cubed, 125. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. And 10 cubed is 1,000. Those are your perfect cubes. Again, you don't really have to memorize this. Up to 5, really up to 6 is great. Knowing up to 10, though, is really helpful because that's really what you'll see if it is a perfect cube. You're not going to really see anything beyond 10, and you can always use a calculator to help as well. So those are your perfect squares, perfect cubes. So given the perfect squares and the perfect cubes now, we're going to be able to solve various examples now using the calculator, using our knowledge of squares, square roots, cubes, cubed roots to answer questions. So now we're going to go to the worksheet. So it says square roots and cube roots. We want to find each value. So here we got some with exponents of 3, 2, and then we have our square root, cube root, and so on. So we just have to find each value. So 2 cubed really just means 2 times 2 times 2, which is 8. Or on my calculator, I just do 2, and then I find the cube button, which I said was second 1, 8. 6 squared, that's just 36. That's 6 times 6. And then 11 squared, that's on our list of perfect squares. That's 121. 11 times 11. Okay, the next part now, it says square root 25. So I type in 25, and then I hit the square root button, 5. It's saying what number times itself is 25? This is 5. Now I see the little 3. That means cubed root. What number times itself is 27? And that is one of mine. 27, that's 3 cubed, so it's 3. Okay, number 6, we have a negative, and it's okay if you have negatives too, because remember, 2 negatives multiplied together equal a positive, 3 negatives multiplied together equal a negative. So cubed root of negative 125, what number can I multiply by itself and by itself to give me negative 125? If I look, 125 is 5, but since I have a negative number, I'm going to say it's going to be negative 5. And let's just check, because sometimes when you do it, you could get an error. So 125, second, 0. But let's type in negative 125 now. 125, negative, second, 0. Negative 5. Because negative 5 times negative 5 times negative 5. 3 negatives equal a negative. 2 negatives equal a positive. 7, square root of 100. What number times itself is 100? That's 10. What number times itself is 16? That's 4. And what number times itself is 1,000 for cube, and that is 10. So again, having this sheet readily available with your perfect squares and perfect cubes does make it a lot easier. And you can always use your calculator if it's bigger numbers. Now it says, determine the two positive integers each square root falls between. So we talked about rational, irrational. And here's my strategy. Let's just type in 28 and take the square root. I get 5.29150262. Notice it keeps going on and on, even though it stops on the calculator. The calculator can't fit all the numbers, so it just stops, it rounds it off there. But it's really going on forever. And there's no pattern here. Even if you see 2, 2, it's not going to be 2's repeating. It just goes on and on, no pattern. This is an irrational number. It's a non-perfect square. Because if I look on my list of perfect squares, I don't see 28 anywhere. This is saying determine the two positive integers each square root falls between. So we know it's 5.29, so it's going to be between 5 and 6. So this is a strategy if you didn't have a calculator. If I know my perfect squares, I look and see 28, which two it falls between. So 28 is between 25 and 36. 25 was 5 squared, 36 was 6 squared. So it's between 5 and 6. So find what two perfect squares it's between, and you got your answer. If you don't want to use this way, just put it in on your calculator and then figure out what two numbers it's between. So this is between 5 and 6. Square root of 3. If I look on here, 3 is between 1 and 4. That's 1 squared and 2 squared. So it's going to be between 1 and 2. And I can check on my calculator. Square root of 3 is 1.73, and that is between 1 and 2. Square root of 59. 59 is between 49 and 64. That's 7 squared and 8 squared, so 7 and 8. Square root of 15 is between 9 and 16. That's 3 squared and 4 squared, so 3 and 4. Square root of 72. That's between 64 and 81. That's 8 and 9. And then square root of 140. That's between 121 and 144. That's 11 and 12. And again, you can use your calculator to help you too. But if you know your perfect squares, then you don't have to use it at all. It might go a little quicker. 16 through 18. Approximate each square root to the nearest tenth. We're just going to use our calculator here and then round it. We know square root of 8 is between 4 and 9, 2 squared, 3 squared, so it's between 2 and 3. So let's just see exactly what number. Square root of 8 is 2.82. If I look after the 8, it's a 2, so that means I'm going to leave it as 2.8. If it's 5 or up, I round up. So it's just 2.8. This is 2.82, and this rounds to 2.8. Square root of 19 is between 4 and 5. If I do it on a calculator, I get 4.35, so I'm going to write that. Now I'm going to round it. Since it's the number after the 10th place is a 5, I round up, so it becomes 4.4. Square root of 30. Between 25 and 36, so it's 5 and 6. So let's just make sure. Square root of 30 is 5.477. So 5.47. After the 4, it's a 7, so I round up. So it's going to be 5.5. That's how you approximate square roots to the nearest tenth. I can do the same with cube roots by just hitting the cube root button. Number 19. Mountain View Middle School students work on square desktops. The area of the square desk surface is 4 square feet. What is the length of each side of the desktop? So we have a square. We know the area equals 4. So if we go back to our paper from before, this is, okay, when I'm given the area, I need to figure out what each side is. So I'm going to use this one, the second one. So I do the square root. So what number times itself is 4? So I just do the square root button. And that's an easy one. It's just the perfect square. So 4 square root is 2. So each side equals 2. Number 20, the volume of a cube is 64. What are the lengths of each side? So I look at my 4 cases. In this case, I'm given the volume, so I'm going to be using cubed root, the 4th case. What number times itself is my volume. So I just do the cubed root. So in this case, I want to just do the cubed root of 64. And if I do that, that is a perfect cube. So second 0 gives me 4. So each side is 4 feet. And number 21, a square garden has an area of 144. How many yards of fence will it take to enclose the garden? So the first thing I'm going to do is figure out what each side is. So again, this is very similar to number 19. We're going to use case 2. Given the area, find what the side is. So I do square root. Square root of 144. I do that, that's a perfect square. That gives me 12. So 12 feet is each side. But it's saying, how many yards of fence will it take to enclose the garden? So enclose means perimeter. So basically I have a square. Each side is 12. So the perimeter is 48 feet. But it's asking for how many yards of fence. So if 48 feet, how many yards is that? I use my conversion. 1 yard is 3 feet. And we did talk about that in another video about the conversions. So if 1 yard is 3 feet, how many yards is 48 feet? So I set up a proportion. 1 over 3 equals x over 48. Cross multiply. So I get 3x equals 48. Divide by 3. I get x equals 16. So it's 16 yards. 16 times 3 is 48. So that concludes this video with square roots and cube roots. You should now have a basis of understanding for how to write a square root, how to write a cube root, how to find a perfect square, how to find a perfect cube, what a rational number is, what an irrational number is, and how to solve questions involving area and volume of cubes and squares, how to approximate a square root to the nearest tenth or to the what 2 numbers it's between, and how to evaluate each number. So this is Mr. Holmes signing off, and enjoy the rest of your day. Take care. Bye-bye.